students, it's day 1 for the chapter Atomic Structure. The objectives of the chapter are introduction to the topic, then what is atom, atomic number, mass number, element, compound, chemical symbols, atomicity, periodic table, chemical formulae of elements, chemical formulae of compounds, radicals and valency. The specific objectives for today's topic are introduction of the atom. Atoms consist of electron, proton and neutron. Terminology related to atomic structure, and last is chemical symbols of elements. So open page number 59 of your chemistry textbooks. Our first topic for today is what is an atom. Students, matter is made up of tiny invisible particles known as atoms. An atom is made up of electrons, protons and neutrons. Now students, let's discuss some important terms related to atomic structure before proceeding further. First is atom. An atom is defined as the smallest particle of matter which may or may not exist independently. Now next is nucleus. The central part of an atom consisting of nucleons is called nucleus of an atom. Now what are nucleons? Protons and neutrons which are present in the nucleus of an atom are collectively called as nucleons. Now next is protons. P for proton, P for positively charged. A positively charged particle that is present in the nucleus of an atom is called a proton. And next is neutron. A heavy uncharged particle that is present in the nucleus of an atom is called a neutron. Next subatomic particle is electron. A negatively charged particle that revolves around the nucleus of an atom. This is nucleus of an atom, and these particles revolve around the nucleus of an atom. They are called as electrons. Now once again see the definitions. Electron, a negatively charged particle that revolves around the nucleus of an atom in its definite orbit is called an electron. A positively charged particle that is present in the nucleus of an atom is called a proton. And a heavy uncharged particle that is present in the nucleus of an atom is called a neutron. Next is atomic number. Students, in a nucleus of an atom, there are protons. And the total number of protons present in the nucleus of an atom is called its atomic number. Next is mass number. The sum total of protons and neutrons present in the nucleus of an atom, that means how many nucleons are present in the nucleus of an atom, is called its mass number. Now students, can you see these concentric circles? These are definite energy shells. An electron can revolve in its own energy shell, in its own definite energy shell. The definite energy shells in which electrons revolve are called orbits. Now students, this is first energy shell and this is second energy shell. You can see the electrons in this shell. This is last shell or outermost shell of this atom. The electrons that are present in the last shell or the outermost shell of an atom, they are called as valence electrons. Next is valency. The combining capacity of an atom of an element is called its valency. That is how much of electrons can be given or taken by an atom of an element. Now students, please note this terminology in your fair copies. What is an atom, electron, proton, neutron, nucleus, atomic number, mass number, orbits, valence electrons and valency. Now students, in 6th standard you must have done the terms an element and a compound. An element is defined as a pure substance which is made up of same kind of atoms. Example, iron, sulfur, sodium, potassium, phosphorus, nitrogen, oxygen, carbon, etc. Compound. Compound is defined as a pure substance which is made up of different kind of atoms combined together in a fixed ratio. Example, carbon dioxide, which is made up of carbon and oxygen. Then we'll take another example of sulfur dioxide, which is made up of sulfur and oxygen. Then I'll be taking another example of aluminium carbonate, which is made up of aluminium, carbon and oxygen. So these are the examples of compound, which are made up of different kind of atoms combined together in a fixed ratio. Now next we are going to discuss is the difference between atomic number and mass number. The total number of protons present in the nucleus of an atom is called atomic number. And mass number, the sum total of protons and neutrons present in the nucleus of an atom is called mass number. Atomic number, it is written at the base of an element. Mass number, it is written at the top of an element. Atomic number, it is denoted with capital Z. Mass number, it is denoted with capital A. Let X be any element, then A denotes mass number and Z denotes atomic number. Now next we are going to discuss is name of an element, its symbol, its atomic number and mass number. Before discussing this chart to you, I'll be discussing how we can calculate the mass number of an element if its atomic number is given to you. I have taken two examples here. Sodium, whose atomic number is 11, that is odd. If atomic number of an element is odd, then you will multiply it with 2 and will add 1 to it. So 22 plus 1, that will be 23. So its atomic number is 11 and its mass number will be 23. Now next I have taken oxygen. 8 is its atomic number, it's even. So we'll simply multiply it with 2 and whatever the answer comes, that is its mass number. So 16 is the mass number for oxygen, whose atomic number was 8. Now let's see this chart. This is name of an element. Symbol. Symbol is defined as the short form of an element, atomic number and mass number. List of elements. First is hydrogen, symbol H, atomic number 1, mass number 1. Hydrogen has an exception to mass number. Next is helium, symbol He, atomic number 2, mass number 4. Lithium, symbol Li, atomic number 3, mass number is 7. Beryllium, symbol Be, atomic number is 4, mass number is 9. Beryllium also has an exception. Boron, symbol B, atomic number 5, mass number 11. Carbon, symbol C, atomic number 6, mass number 12. Nitrogen, symbol N, atomic number 7, mass number 14. Nitrogen also has an exception in its mass number. Oxygen, O, atomic number is 8, mass number 16. Fluorine, symbol F, atomic number 9, mass number 19. Neon, symbol Ne, atomic number 10, mass number 20. Sodium, symbol Na, atomic number 11, mass number 23. Magnesium, symbol Mg, atomic number 12, mass number 24. Aluminium, Al symbol, atomic number 13, mass number 27. Silicon, symbol Si, atomic number 14, mass number 28. Phosphorus, symbol P, atomic number 15, mass number 31. Sulfur, symbol S, atomic number 16, mass number is 32. Chlorine, symbol Cl, atomic number 17, mass number is 35. Argon, symbol Ar, atomic number is 18, mass number is 40. Potassium, symbol K, atomic number 19, mass number is 39. Calcium, atomic number 20, symbol is Ca and mass number is 40. Students, argon also has an exception. Its atomic number is 18 but its mass number is 40. Now let's start with the reading of the chapter on page number 59 of your chemistry textbooks. Chapter 4, Atomic Structure. Introduction. Just as a building is made up of bricks, similarly all elements are made up of atoms. If same kind of atoms join together, we get a homoatomic substance. Homo means same and they are called elements like oxygen, nitrogen, etc. If different atoms join together, we get a heteroatomic substance. Hetero means different like water, carbon dioxide, etc. These homoatomic substances are also known as elements and heteroatomic substances as compounds. Now next is atom. An atom is the smallest particle of element. Students, an is missing here. An atom is the smallest particle of an element that takes part in a chemical reaction. Underline, this is the definition of an atom. An Indian philosopher, Kannad, was one of the first person to propose that matter is made up of very small particles called Parmanu. John Dalton called these particles atoms. The word atom means invisible. Inside the atom, there are present a variety of even tinier particles called subatomic particles, which we have already discussed. They are electrons, protons, and neutrons. Atoms join together to form molecules. Atoms do not exist independently. They combine with other atoms to stabilize themselves. That is, to make them stable. They may combine with atoms of their own kind or of different kinds. And these linked atoms are known as molecules. If they combine with the atoms of their own kind, they form molecules of an element. And if they combine with the atoms of different kind, they form molecules of a compound. Inside atoms. Atoms are the main building blocks of matter. Inside the atoms, there are present a variety of even tinier particles called subatomic particles. These are protons, positively charged particles, neutrons, uncharged particles, and electrons, that is, negatively charged particles. An atom has a central part called nucleus containing the subatomic particles named proton and neutron. Underline proton and neutron, write down collectively called as nucleons. Electrons are present outside the nucleus and they revolve around the nucleus in definite orbits known as energy shells. I have discussed this terminology with you all previously. That is, what is proton, what is an electron, what is a neutron, what do you mean by energy shells, what is a nucleus, then what are nucleons. Atomic number. Atomic number is the number of protons present in the nucleus of an atom of an element. We all have done this definition. It is represented by capital Z. Atomic number is equals to number of protons. But number of protons is equals to number of electrons in an atom, as an atom is electrically neutral. Just see your yellow box. Atom is electrically neutral because number of protons is equals to number of electrons. As a result, total positive charge is equal to negative charge on an atom. Remember, atomic number cannot be the number of electrons. Why? Since the number of electrons change during the chemical reactions, but proton number does not change. Mass number. The total number of protons and neutrons inside the nucleus of an atom is known as mass number or atomic mass of the atom. Mass number denoted with capital A is equals to number of protons plus number of neutrons. For example, oxygen atom has 8 protons and 8 neutrons in the nucleus. Its mass number is 16, 8 plus 8. Sodium atom has 11 protons and 12 neutrons in the nucleus. Its mass number is 23, 11 plus 12. Relative atomic mass. Relative atomic mass is the number which tells how many times an atom of that element is heavier than an atom of hydrogen. That is, we will find the ratio of atomic weight of any element with the atomic weight of hydrogen. Then whatever the answer or result comes, that is relative atomic mass. For example, the atomic weight of nitrogen is 14. This means that one atom of nitrogen is 14 times heavier than one atom of hydrogen, as atomic weight is in ratio, hence it does not have any unit. Element. An element is the simplest form of a pure substance which cannot be divided into any other simpler substance. An element is also defined as a pure substance which is made up of same kind of atoms. Elements contain similar kinds of atoms. Identical is same in all respects. Example, oxygen gas with only oxygen atoms. So, oxygen is an element. Compound. A compound is a pure substance made up of two or more elements chemically combined in a fixed ratio by weight. For example, water is made up of hydrogen and oxygen, that is different atoms. Mass of hydrogen, we know it's 1. Mass of oxygen atom, 16. So, 2 atoms of hydrogen combines with 1 atom of oxygen to form water. So, 2 multiplied by 1 and 1 multiplied by 16. So, 2 ratio 16, which comes up as 1 ratio 8. Thus, water contains hydrogen and oxygen in a fixed ratio of 1 ratio 8. Chemical symbols. There are many examples where we use short names or abbreviations in daily life situations. In the similar way, in chemistry, shortened forms of names of elements are present which are known as symbols, or you can simply say a short form of an element is called symbol. Ancient alchemists were using few difficult and complicated symbols for elements and compounds which are shown below. You can see such complicated symbols. Then John Dalton proposed the use of symbols to represent the atoms of various elements. Dalton's atomic theory. Matter is made up of tiny particles called atoms. Atoms are indivisible. They cannot be divided. Atoms cannot be created or destroyed. Atoms of the same element are identical in mass and other properties. Like oxygen, a single atom of oxygen, whatever its atomic mass is there, it will be identical for another atom of oxygen. Atoms of different elements differ in their masses and properties. Like atomic mass of hydrogen will be different from atomic mass of oxygen or of sodium or atomic mass of chlorine. J.J. Berzelius introduced the modern system of naming elements by their symbols. Some elements were named on the basis of their starting letter. Example, C for carbon, O for oxygen, H for hydrogen, B for boron, N for nitrogen. Some elements were named on the basis of their first two letters when the first letter was already chosen. For example, C was chosen for carbon, then CO for cobalt, and O was chosen for oxygen, then OS for osmium. Some elements were named on the basis of their Latin names. Example, K for potassium, as P for phosphorus was already there, so K was given to potassium, Latin name Kalium. Na for sodium, as S was for sulfur, so Na for sodium, as its Latin name is natrium. Significance of symbols, that is importance of symbols. Symbol of an element signifies name of the element. If I write O, I know that is a symbol for oxygen. So it is representing oxygen. An atom of the element. O, it is telling me that we are talking about one atom of oxygen. Convenience to write the name of the element. If I am writing C, O, S, I am knowing that I am writing its carbon, oxygen and sulfur. Requires of less time and space, as it is an abbreviation, short form, so it requires less time to write a symbol and less space too. Learning outcomes of today's topic are: what is an atom? Particles inside an atom, that is subatomic particles, proton, neutron and electron. Terminology related to atomic structure. List of first 20 elements with their symbol, atomic number and mass number. Then chemical symbols and its significance. Difference between atomic number and mass number.